Hello, fifth graders. We're going to take a look at several strategies for adding decimals. One way that we can add decimals is using base 10 blocks. Let's add 3 7/10 to 2 78/100. Here's some examples of base 10 blocks that you're already familiar with. When you were in lower grades, you thought of these as hundreds, tens, and ones. But now that you're in fifth grade, you understand that each time you move left in a number, the digits are 10 times bigger, and each time you move right, the digits are 1/10 in size. So really, you could use these blocks for any place value. So that if the flat is hundreds, whatever is to the right has to be 1/10 of it, and whatever is to the right of that has to also be 1/10. So it needs to be 3 consecutive place values, but it doesn't matter which place values you use these to represent. So for example, instead of using these for hundreds, tens, and ones, what if we called this ones? Now we know that when we move right, the value of the digit is 1/10, and it's 1/10 in size. So whatever is the next place value over, in this case tenths, the block that we're using needs to be 1/10 the size of the one. So we could use the flat for ones, the rod for tenths, and again, when we move one place right, the block that we're using would need to be 1/100th of a whole, or 1/10 of a tenth. It takes 10 of the hundredths block to make a tenth block, and it takes 10 of the tenths block to make a ones block. Okay, so let's use these, because if we look at our problem, 3 7/10 has a ones place and a tenths place, and 2 78/100 has a ones place, a tens place, and a hundredths place. So we can use these blocks as we have them labeled now to represent this problem. So this would be 3 ones and 7/10. These base 10 blocks are representing 3 7/10. The orange base 10 blocks represent 2. These blocks represent 7/10 because they are 1/10 of the full size 1. And these represent hundredths because it takes 10 of this size block to make the tenths, and it takes 10 of the tenth size block to make a whole. So now what we have represented are 3 7/10 in purple and 2 78/100 in orange. What we need to do is to combine these two, because that's what adding is. So what we need to find out is if we put all of these in one pile, how much would we have? Let's move them so it will be easier to see. Okay, so now we have all of the ones together, we have all of the tenths together, and now we have all of the hundredths together. We have 5 wholes, that's ones, we have 14 tenths, and we have 8 hundredths. Now, we can't just write the number as 5.148 because there's only one digit allowed in a place value, because we know that as soon as we have 10 in a place value, we need to regroup those and move those to the left, because it takes 10 to make the next place value to the left. So since we have 14 tenths, we're going to be able to take 10 of those and change those into a whole. So let's do that now. So now that we move 10 tenths into a whole, instead of having 5 wholes, we have 6 wholes. Instead of having 14 tenths, we have 4 tenths, and we still have 8 hundredths. So now we could say our total is 6 48 hundredths. Let's look at another problem. So what if we wanted to add 1 457 thousandths to 2 19 hundredths? Now our first number has ones, tenths, a 4 in the tenths place, 5 hundredths, and 7 thousandths. But the blocks we used in the first problem, we only had ones, tenths, and hundredths. So we could cut our hundredths apart, but if you were using base 10 blocks, they're plastic and they're hard, so that would be really hard to do. But the good news is there is another place value block that's even bigger. When you were in third grade, you called that the thousands block. Remember, it doesn't matter which block we use for which place value, it just needs to be 4 consecutive place values, right? What if we were to move those 3 over and use that big cube for the ones? We have the big cube for the ones, so we have to think about what would 1/10 of that be for the tenths place. That would be a flat. what would 1/10 of a tenth be for the hundredths, and that would be the rod, and what would 1/10 of the hundredths be for the thousandths, and that would be the tiny cube. The first number has 4 place values, so we could use these cubes to represent 1 and 457 thousandths. 2 and 1900ths only has hundredths, but since it's in the same problem, we're going to use the cubes just like this also to represent 2 and 1900ths. Let's try that now. So now we have a green 1 that represents 1 whole. We have 4 tenths, that's 1/10 of what a whole is. We have 5 hundredths. Each of those hundredths is 1/10 of a tenth, and that's what makes it a hundredth. You can also think about it takes 100 of those to make the ones cube, so that's why it's called hundredths. And we have 7 thousandths, and so you could think about the fact that it takes that each of those thousandths cubes is 1/10 of a hundredth here, or if you refer back to the whole, it would take 1,000 of those tiny cubes to build the 1, so it's 1/1000ths. What we have now is representing 1 and 457 thousandths. Let's represent 2 and 1900ths. We can begin with 2 wholes, 1/10, and 9 hundredths. Now we're adding, so just like in the first problem, one thing that we want to do is to combine these blocks. So let's move them around so it'll be easier for us to see how many of each kind of block we have. Now we have the 3 ones, 5 tenths, 14 hundredths, and 7 thousandths. For the hundredths, we have 14 hundredths, and remember, anytime we have 10, we're going to regroup that into the next place value over. 10 hundredths, and move it over so that we have an extra tenth. Now we have 6 tenths and 4 hundredths. So our total is 3 ones, 6 tenths, 4 hundredths, 7 thousandths. 3 and 647 thousandths. We can also add decimals using decimal grids. Let's say we wanted to add 2 and 34 hundredths to 1 and 8 tenths. We could represent 2 and 34 hundredths like this. We can color in 2 wholes and 3 tenths. Notice that one column would be 1/10 of this shape. If we would only have the vertical lines, there would be 10 vertical lines going up and down. So every time you have a complete column, that would be 1/10. And since we have 3 of those, that's 3 tenths. And then there's another column that's not quite full, so each one of those tiny boxes represents 100. So we have 2 wholes, the 3 full columns represent 3 tenths and 4 hundredths. Or you could think of that as 34 hundredths. We're going to add that to 1 and 8 tenths. So when we look at this picture, we see 1 whole shaded, and this time the second block is partitioned into tenths, and 8 of those tenths are shaded. So 1 and 8 tenths. Again, we're going to combine these two. We don't really have to do anything to the holes because they're holes, they're filled in. But what we need to do is think about what could we do with these 2 decimal grids that are partially filled in. And it looks like to me it would be really easy to move 2 of those columns that are on the blue over to the green, and then we'll have another full decimal grid. Let's see what that would look like. So when we move it over, now we took 2 of the columns and we put them over on this decimal grid. So now we have 4 complete holes, and then on the one that's partially filled in, there is 1/10 and 4 hundredths. Or we could think of that as 14 hundredths. So what we have is 4 and 14 hundredths. What if you didn't have decimal grids or base 10 blocks? This is just like when you were adding whole numbers within 1,000 when you were in 3rd grade. You just had to make sure you added thousands to thousands, hundreds to hundreds, tens to tens, and ones to ones. Well, it's the same thing with place value under 1. We're still adding the ones to ones, of course, but you have to make sure that you're adding tenths to tenths, hundreds to hundreds, and thousands to thousands. If there's not a place value, you just pretend like it's 0. So in this case, what we would have to do is add the ones to the ones. 2 ones plus 1 1 is 3 ones. 3 tenths plus 8 tenths would make 11 tenths. So it's 11 of those rods would be a whole and 1 left over. And then 4 hundredths is all by itself. 1 and 8 tenths didn't have any hundredths, so it's just like adding 0. So it's just kind of there. So now let's put these together. Let's put 3, 1 and 1 tenth, and 4 hundredths together. 3 and 1 and 1 tenth would be 4 and 1 tenth. And then 4 and 1 tenth and 4 hundredths would be 4 and 14 hundredths. Let's take a look at this with thousandths. Let's say now you are trying to add 734 thousandths to 89 hundredths. These are thousandths grids and they have really small parts. 734 thousandths represented by red. Notice there are 7 full columns because the full column, remember, is a tenth. Each time there's a column, it's a tenth of the whole grid that you see there. So there's 7 full columns. Then the 3 is in the hundredths place. So there are 3 hundredths shaded in the next column. And the reason that's a hundredth is because it would take 100 of those to cover the whole decimal grid. So that would be 3 hundredths. And then remember a thousandths? It takes 10 thousandths to make a hundredth. And so what we had to do is partition that hundredth into 10 equal parts and shade 4 of them. That's why they're all shaded into 10 equal parts. But really, this is showing you 7 tenths, 3 hundredths in the next column, and then in the very next hundredth square, it's showing you 4 thousandths. So look at how small thousandths are compared to tenths. Sometimes boys and girls hear thousandths and they think it's going to be a lot larger because of that word thousandths, but really thousandths are very, very small compared to tenths and still small compared to hundredths. So red is representing 734 thousandths. Blue is representing 8 full rows. That's 8 tenths. And then 9 of the darker boxes are completely shaded in the next column. Those are hundredths. So there are 8 tenths and 9 hundredths shaded, or 89 hundredths. Now, what if we wanted to combine these two? If I'm looking at this visually, I think the easiest thing to do would be to take one of the red columns and put it over on the blue grid and fill that grid completely up. Let's try that right now. Let's move a column over. Now we moved a column from the 7 tenths and we added it to the 89 hundredths. Now the only thing left in this thousandths grid that we need to shade is 100th. So I'm also going to take 100th from the red. Now the right grid is completely full, so that's 1 whole. When we look at our other red one, we can see that there are 6 columns shaded. So now we have 1 whole and we have 6 tenths. The next size box, we can see that there are 2 full boxes filled in, and each one of those boxes 100th of the whole grid. It would take 100 of those to cover the whole grid. So we have 2 hundredths, and then that final box still just has 4 thousandths in it. So there are 4 thousandths. So what we have is 1 whole, 6 tenths, 2 hundredths, 4 thousandths. 1 and 624 thousandths. Now you may not have base 10 blocks, or you may not have access to decimal grids, but remember, this is just like when you added in 3rd grade and you added hundreds to hundreds, tens to tens, ones to ones. You can still do this with just numbers. Let's take a look at that. So I have a picture to kind of show you what we started with and what we ended with, but what we're really going to look at now is what happens to the numbers. So if you don't have grids or you don't have base 10 blocks, you can think in your mind about what's happening. Okay, so let's think about the place values here. We have tenths, hundredths, thousandths, and in this number we have tenths and hundredths. So let's add the tenths together first. So if we put 7 columns together with 8 more columns, we would get 15 columns. So 15 columns, once you had 10 columns, that would have made a whole, right? And then there would be 5 left over. So it would be 1 and 5 tenths. Then we could add the 3 hundredths to the 9 hundredths. And when we add the 3 hundredths to the 9 hundredths, we would get 12 hundredths. That's like taking the 3 red hundredths and putting them with the 9 blue that didn't make a full column. So what happened is basically we moved one of those over to the 9 and we made a tenth, and then there were 2 left over. And then 4 thousandths. There were no thousandths in the blue, so we only had thousandths in the red. So we wouldn't add that to anything. So then we have to put together 1 5/10 with 12 hundredths. That would be 1 62 hundredths. And then we have to add 4 thousandths to that, which would be 1 624 thousandths. So you are able to do these same problems using just numbers, but sometimes it helps to visualize what's happening with base 10 blocks when you're trying to figure out exactly how to put numbers together or how the place values change when you're adding these numbers. Thank you, and if you have additional questions about this, please ask your classroom teacher.